Hi everyone. Today I'm going to present the solution to example 4 by double integration method computing deflection and slopes. So compute the slope and deflection at points A, C, and F. EI is constant. So solve by double integration. So first, let's look at the figure. So if we consider if we section the last segment of the beam, then everything is continuous. So there's nothing to modify the loadings in the B. So let's solve for the reactions at B and E. Let's call that RB and RE. So summation of moment about E equals 0, considering clockwise as positive. So clockwise moment equals counterclockwise moment. So R sub B times 10 then equals 20 times 11.5 plus 180 plus 30 times 5 times 0.5. So solving for R sub B is 48.5 kilonewtons, so it's upward as indicated in the figure. Summation moment about B equals 0, counterclockwise as positive this time. So we have counterclockwise moment equals clockwise moment. So RE times 10 plus 20 times 1.5 plus 180 then equals clockwise moment 30 times 5, then the moment arm is, because this is 0.5, so 10 minus 0.5 is 9.5, so 30 times 5 times 9.5. So solving for RE is 121.5 kilonewtons upward. Now we section EF, and the distance from the left end, let's call that X. So since we only have one equation of the elastic curve, differential equation of the elastic curve. So let's call that X from the left hand. So EI, Y double prime equals RB, which is 48.5 times X minus 1.5. So this distance from this section up to here is X minus 1.5. Then plus RE, which is 121.5, then this distance is x minus 11.5. So 121.5 minus x minus 11.5, then minus 20 times x, then minus 180 because 180 is not acting at the origin. So let's have its moment arm equal to x minus 4.5 to the 0. So this distance supposedly is x minus 4.5. Because this is already a couple, then we just make the power of x minus 4.5 raised to 0. Anyway, that is 1. And the main purpose of that is to make sure that when we compute for deflections and slopes, when we set values of x, remember that when the quantity inside this parenthesis is negative, we simply ignore that term. Then minus this distance is x minus 8.5. So 30 times x minus 8.5, then the moment arm x minus 8.5 over 2. So that becomes 15 times quantity x minus 8.5 squared. So that's the differential equation of the elastic curve. Then integrating once, EI y prime equals 24.25 x minus 1.5 squared plus 60.75 x minus 11.5 squared minus 10 x squared, integral of that, minus 180 x minus 4.5 raised to 1, or x minus 4.5, then divided by 3, minus 5 quantity x minus 8.5 cubed plus c sub 1. So that would be the equation for the slope at any point on the elastic curve. And integrating again, so we'll have 97 over 12 x minus 1.5 cubed plus 20.25 x minus 11 cubed, 11.5 quantity cube, minus 10 thirds x cubed, then minus 90 x minus 4.5 square, then minus 1.25 x minus 8.5 to the fourth plus c sub 1 x plus c sub 2. So both c sub 1 and c sub 2 have values because a is not at the support. So c sub 1, remember, is the slope at a, then c sub 2 is the deflection at a. So let's call this equation 1, equation 2, then equation 3. So we substitute the boundary conditions. When x is 1.5, y is 0, and when x is 11.5, y is 0. So first, for x is 1.5 in equation 3. So when x is 1.5, so 0 equals 0 plus, ignore, minus 10 thirds 1.5 cube, ignore, plus c sub 1 times 1.5 plus c sub 2. So that would be the equation. Simplifying that equation, 1.5 c sub 1 plus c sub 2 equals 11.25. Call that equation A. Then when x is 11.5, y is 0. So still in equation 3. So 0 equals 97 over 12, 10 cube. Then this is 0. So minus 10 over 3, 11.5 cube. Minus 90 times 7 square, this is 7, minus 1.25 times 3 to the fourth, then plus c sub 1 times 11.5 plus c sub 2. So simplifying this equation, we have 11.5 c sub 1 plus c sub 2 equals 1497.5. So we can now solve the two equations simultaneously. You may subtract the two equations, so eliminate c sub 2 and solve for c sub 1, then substitute into equation A rather, and we can solve for c sub 2. So by doing that, c sub 1 equals 148.625 and c sub 2 is equal to negative 211.6875. So remember, c sub 1 is theta A, so divided by EI. So 148.625 over EI, and delta A is negative 211.6875 over EI. So you may express your answer as 148.6, round off to 4 significant figures, and negative 211.7 over EI for delta A. So next is at C. So x is 4.5. When x is 4.5, we can compute theta C and delta C. So in equation 2, 24.25 times 3 square, then ignore, minus 10 times 4.5 square, 0, then ignore, plus c sub 1, which is 148.625. So the theta C is equal to 164.375 over EI, and when x is 4.5 in equation 3, so we have 97 over 12 times 3 cubed, then ignore, minus 10 over 3 times 4.5 cubed, ignore, then plus c sub 1, which is 148.625 times 4.5, and plus c sub 2, which is negative 211.6875. So we can now compute delta C. Delta C is equal to 371.625 over EI, and it is positive. And next is when x is at F, when x is 13.5. So EI theta C in equation theta F in equation 2. So we have EI theta F equals 24.25 times 12 squared plus 60.75 times 2 squared minus 10 times 13.5 squared minus 180 times 9, then minus 5 times 5 cubed, and plus c sub 1, which is 148.625. So solving for theta F, it is equal to negative 183.875 over EI. Since we ran out of space, I will leave that calculation to you. You just substitute in equation 3, x is 13.5, and check that it is delta F is equal to, check this value, negative 347.75 over EI. So thanks for watching, and I hope that you continue to subscribe in my YouTube channel so that you will be updated with the lecture videos that I will have in the future. Then I hope that this video will help you improve your skills in computing deflections. Goodbye. So let's have the other method, area moment method. So from double integration method, we already computed the reaction at B to be 48.5, at E to 121.5 kilonewtons. So based on the figure, it's better to select point P as our moment center. So 48.5 times 3 first degree is 145.5 over EI, then here 485 over EI. So we should compute the moment of this reaction about C, because we are also asked to compute theta C and delta C. Then we have 180 over EI for the focal constant vector here. Then we have second degree for this load. 30 times 3 times 1.5 is 135 over EI, and that is second degree. This is also second degree due to this 30 kilonewton per meter load. 30 times 2 times 1 is 60 over EI. Then for the 20 kilonewton load, moment about E. So moment about B is 20 times 1.5, 30 over EI. 20 times 4.5 at C, 90 over EI. Then at E, 20 times 11.5, 230 over EI. Then we divide this trapezoid into two triangles. So to anticipate the calculations later. So first, let's consider BE, and let's compute deviation of E relative to tangent at B. So we have 1/2 or 0.5 of 10 times 485. The moment arm is 1/3 of 10. So 10/3 minus 7 times 180 over EI times 3.5, the moment arm. And for this spandrel, 1/3 of 3 times 135. The moment arm is 3 over 4, 3 over 4, or 0.75. So 1/3 of 3 times 135, 3 over 4. Then for this small triangle, 1/2 of 10 times 30 times 2/3 of 10 is 20 over 3. Then this big triangle, 1/2 or 0.5 of 10 times 230 times 10/3. So computing for deviation of E relative to B, we have negative 1261.25 over EI. So that means the tangent at B is above E. So above E because the deviation of E relative to B is negative. So the tangent at B should be above E, and point A should be below that reference tangent. So this is theta B because the tangent is inclined up to the right. Theta B is positive. So this is deviation of E relative to B. So from the figure, theta B is 1 over 10. Because tangent theta B is equal to theta B itself, so opposite over adjacent. So since theta B is positive, it is 1 over 10 times the absolute value of negative 1261.25 over EI. So theta B is 126.125 over EI. Now that we have found theta B, let's consider EB to solve for theta A and deflection at A. So AI theta EB is the area between A and B, so 1/2 or 0.5 of 1.5 times negative 30. So theta AB is negative 22.5 over EI. Similarly, EI deviation of A relative to the tangent at B is the moment of this area with respect to A. And the moment arm is 2/3 of 1.5 is 1. So 0.5, 1.5, negative 30 times 1. So it is also negative 22.5 over EI. So let's draw so that we can analyze theta A and delta A. So if this is the line, B is on the horizontal line, A is below because deviation of A relative to B is below the reference tangent at B. So let's draw the tangent at B. Remember that this is theta B, which is positive, inclined up. Then the location of A should be here, below the reference tangent, because deviation of A relative to B is negative. This is, considering this right triangle, is 1.5 theta B. And this is the location of A at the bottom. Then this is deviation of A relative to B, which is negative. So analyzing, we draw the line tangent to A. Then from tangent to A to tangent to B, because theta AB is negative, it should be clockwise. So the tangent at A should intersect the tangent at B. Then it should be above, so that when we measure this angle, it is clockwise. So this is theta AB, which is negative because it is clockwise. And if you draw a horizontal line from A, then to the tangent at A, so this is theta A. Then from the intersection of the two tangents, we draw a horizontal line. So take note that tangent at B, horizontal line is theta B. So tangent at B, horizontal line, this is also theta B. So if that is the case, theta A is positive because it is inclined up to the right. It is the absolute value of theta B plus absolute value of theta AB. So theta A is positive, absolute value of theta B plus absolute value of theta AB. So combining, theta A is positive 148.625 over EI, just like in double integration method. Then the deflection at A is negative because this is the horizontal line, this is the x-axis supposedly, and A is below the x-axis, so it is negative of absolute value of 1.5 theta A, theta B plus absolute value of deviation of A relative to B. So theta A is negative of absolute value of 1.5 of theta B plus absolute value of deviation of A relative to B. So delta A is negative 211.6875 over EI, just like in double integration method. Then let's consider BC, because we are also asked to compute theta C and delta C. So EI theta BC is the area of the diagram, so quantity 0.5 of 3 times 145.5 plus, so let's consider this as a trapezoid. Anyway, we're just computing area. Minus of quantity 0.5 of 30 plus 90 times 3. So that's the area of the trapezoid. We subtract it because the area is negative. So theta BC is 38.25 over EI. It is positive. So it means that from tangent at B to tangent at C, it should be counterclockwise because this is positive. Then EI division of C relative to B is moment about C of area. So quantity 0.5 times 3 times 1 for 5.5 times 1/3 of 3 is 1. Then let's break this trapezoid into two triangles, one with height 30 and the other with height 90. But remember, they are negative. So minus quantity 0.5 times 3 times 30 times 2. So the centroid of this triangle from C is 2. The centroid of this bigger triangle from C is 1. So minus 0.5 of 3 times 90 times 1. So simplifying, deviation of C relative to B is negative 6.75 over EI, which means that point C is below the reference tangent of B. So that we can analyze it well, let's draw the figure. So we have B on which remains on the horizontal line because it is a support. C should be above, but it should be below the tangent of B. So if this is the tangent line of B, this is theta B, then this is C because the deviation is very small, but it is negative. Then this is deviation of C relative to B. Then this should be the tangent at C, so that from tangent at B to tangent at C, it is counterclockwise. So this is theta C, angle that the tangent at C makes with the horizontal. This is theta BC, which is positive because that's counterclockwise. If we draw a horizontal line through the intersection, take note that this angle here with the horizontal and this tangent at B is theta B. So that is theta B there. Therefore, theta C, which is up to the right, is positive, and it is equal to theta B, absolute value of theta B, positive of quantity absolute value of theta B plus absolute value of theta BC, although they are both positive. Likewise, this is delta C, which is above the x-axis, so delta C is also positive. And this is the entire height of this right triangle is 3 times theta B, or tangent theta B is opposite over 3. So tangent theta B is theta B itself, so this opposite is 3 times theta B. So from the figure, theta C is a positive of absolute value of theta B plus absolute value of theta BC. So theta C is equal to 164.375 over EI. And from this figure here, delta C is absolute positive. So it is positive of absolute value of 3 theta B minus absolute value of deviation of C relative to B. And this should be the elastic curve. It should look like that. So that this portion is tangent to B and that portion is tangent to C. So EI delta C is positive of 3 times theta B, absolute value of theta B minus absolute value of deviation of C relative to B. So delta C is positive 371.625 over EI. So next we consider deviation of B relative to the tangent of E, so that we can compute the slope of the tangent of E. Then finally we consider EF in the next slides. Okay, before proceeding to EF, let's consider back BE to determine the slope at E. So EI deviation of point B relative to the tangent at E is equal to, considering areas between B and E. So we sum up moment about B. So we have 1/2 or 0.5 times 10 times 485. Then the moment arm is 2/3 of 10 or 20 over 3. Then minus 7 times 180. So 3.5 plus 3. So the moment arm is 6.5. So minus 7 times 180 times 6.5. And minus 1/3 of 3 times 135. Since this is 3 over 4 or 0.75, its distance from the left end from B is 9.25. So minus 1/3 of 3 times 135 times 9.25. Then considering this small triangle, minus 0.5 of 10 times 30 times 10/3. Then lastly for this triangle, big triangle 1, minus 1/2 or 0.5 of 10 times 230 times 20 over 3. So solving for the deviation of E relative to E, it is equal to negative 1,438.75. So that means point B is below the tangent of E. So if this is BE, the tangent should be above and B should be below. So this is deviation of B relative to the tangent at E. So the slope of the tangent at E therefore is negative because this is down to the right. And this is theta E. So theta E is negative. So it is negative 1 over 10 of deviation of E relative to E. So 1 over 10 times negative 148.75 over EI. So theta E is negative 140.875 over EI. Now let's consider EF. And let's compute EI theta EF. it is equal to negative 1/3, because this is negative, so 1/3 of 2 times 6, 1/3 of 2 times negative 60 over EI, so negative 40 over EI theta EF. So that means that the tangent at E to the tangent at F, the rotation is clockwise because of this negative sign. Then deviation, EI deviation of F relative to the tangent at E is quantity 1/3 of 2 times negative 60 over EI, then the distance is 1.5. Distance of the centroid of this second degree curve, area of this spandrel from F is 1.5, because supposedly this is 2 over 4 or 0.5, so that would be 1.5, 2 minus 0.5. Then it is equal to negative 60 over EI. So that means that that point F is below the reference tangent at E. So if we draw E, and we have 2 meters here, so we draw the tangent at E, which is negative, and this is supposed to be 2 times, that is theta E, so this is 2 times theta E. Then point F should be below the reference tangent because deviation of F relative to tangent at E is negative. So this is the elastic curve, so this should be F, and this distance is deviation of F relative to E, which is negative. So from the figure, we draw the tangent at F. So this is the tangent at F. The angle that the tangent at F makes with horizontal is the slope at F, which is this, theta F. This is theta EF, which is clockwise, negative 40. And this is the angle at F, or the slope at F, theta F. We draw a line from the intersection of the two tangents. This is theta E, and therefore it is clear that theta F is this angle here, the angle that the tangent at F makes with horizontal. That's the slope at F. And it is negative. It is the negative of quantity absolute value of theta E plus theta EF, absolute value of theta EF. So from the figure, this is theta F, and the deflection at F is negative. It is below the horizontal. It is the negative of absolute value of 2 theta E plus deviation, absolute value of deviation of F relative to E. So theta F is negative of theta E plus absolute value of theta E plus absolute value of theta EF. This is theta E, absolute value, plus absolute value of theta EF. So it is negative 183.875 over EI, just like in the preceding two methods. Then likewise, summation of moment, or delta F, is equal to negative of absolute value of 2 theta E plus absolute value of deviation of F relative to E. So delta F is negative 347.75 over EI, which is the same as the answer to the preceding double integration method. So that's it. So let's have the third method, which is the conjugate beam method. So let's have the conjugate beam method. So solution by conjugate beam method. So we just modify the supports. So we use the same area moment diagram from area moment theorems. Then this free end becomes fixed. This pin becomes interior hinge. This roller becomes interior hinge, and this free end becomes fixed end. So we put the positive slopes and positive deflection at various points. So we have theta A upward, clockwise, delta A, assume positive deflections, and of course corresponding shear and moment respectively. Then at B, just to the left, downward, and upward for positive shear or theta at B. Then at E, down, just to the left, up, just to the right. So that's it. So let's consider first portion BE. So we can solve theta E. So summation moment about E equals 0, clockwise positive. So we have theta B times 10 plus quantity moment of this area, 1/2 or 0.5 of 10 times 485 over EI times moment arm 10/3 or 1/3 of 10. Then minus the moment of this rectangular area for the couple, 7 times 180 over EI times 3.5. Minus this spandrel, 1/3 of 3 times 135. The moment arm is 3 over 4 or 0.75. 1/3 of 3 times 135 over EI times 3 over 4. Then we have here a trapezoid that's divided into 2. We have this small triangle first, minus 1/2 or 0.5 of 10 times 30 over EI times 20 over 3, the moment arm. And lastly, minus 1/2 or 0.5 of 10 times 230 over EI times 1/3 of 10 or 10/3. So equals 0. So computing theta B equals 126.125 over EI. Then summation forces Y equals 0. Let's solve theta E in advance for the deflection and slope at F later. So summation forces Y equals 0. We have theta B, which is 126.125 over EI plus 0.5 of 10 times 485 over EI, then minus 7 times 180 over EI, minus this spandrel, 1/3 of 3 times 135 over EI, then minus this trapezoid. So let's treat this as a trapezoid because we are just computing for the area. So minus 1/2 or 0.5 of quantity 30 over EI plus 230 over EI times 10. Then equals 0. Minus theta E rather equals 0. So solving for theta E equals negative 140.875 over EI. Now let's consider AB. First, summation forces Y to solve for theta A since we have found theta B. So theta A, then minus 1/2 or 0.5 of 1.5 times 30 over EI. So theta A minus 0.5 of 1.5 of 30 over EI minus theta B, which is 126.125 over EI equals 0. So solving for theta A equals 148.625 over EI, just like in the double integration method. And summation moment about A, clockwise positive. So we have delta A, then this, because this is downward, plus 0.5 of 1.5 of 30 over EI times 1. The moment arm is 1. 2/3 of 1.5 is 1. Then minus theta B, which is, plus theta B, because it is also clockwise. Theta B is 126.125 over EI times 1.5 equals 0. So solving for delta A is equal to negative 211.6875 over EI, just like in double integration method. So let's now consider EF. So we put theta F, which is down, and delta F to be assumed positive counterclockwise. Consider BC first. Sorry. Let's solve for theta C and delta C. So we put downward here, summation forces Y equals 0. So theta C is down to be positive, and for the right section up, and the positive deflection is counterclockwise. So for the other side, up and clockwise. But we consider only BC first, summation forces Y equals 0. So you have theta B 126.125 over EI plus area of this triangle, which is 1/2 or 0.5 of 3 times 145.5 over EI, then minus this area of trapezoid. So 1/2 or 0.5 of quantity 30 over EI plus 90 over EI times 3, then minus theta C equals 0. So solving for theta C is 164.375 over EI, just like in double integration method. Then summation moment about C equals 0 in the next slides. So let's sum up moment about C considering BC. Clockwise positive, so we have theta B 126.125 over EI times 3, then plus 1/2 of 3 or 0.5 of 3 times 145.5 over EI times 1, because we sum up moment about C. Then we divide this trapezoid into two triangles. Let's consider first the small triangle. Minus 0.5 of 3 times 30 over EI, then times 2. The moment arm is 2, 2/3 of 3 is 2. Then for this bigger triangle, minus 0.5 of 3 times 90 over EI times 1/3 of 3 is 1. Then minus delta C equals 0. So solving for delta C equals 371.625 over EI is positive. This is the same as the result of the previous two methods. Then finally, we consider EF and take note that we already computed theta E, which was negative 143.875 over EI. And considering EF, so we assume theta F to be positive, so it is down, and delta F to be positive counterclockwise. So theta F down, counterclockwise delta F, and summation versus Y equals 0 to solve for theta F. So we have theta E negative 140.875 over EI, then minus, because it is negative, then minus this area of spandrel, 1/3 of 2 times 60 over EI, then minus theta F equals 0. So there is only one area. So theta F equals negative 183.875 over EI, just like the answer to the previous two methods. Finally, summation moment about F equals 0, clockwise positive. So we have theta E times 2, or negative 143.875 over EI times 2. Then minus, this is counterclockwise, minus area of spandrel, minus quantity 1/3 of 2 times 60 over EI. Then the moment arm is 1.5 because this distance is supposedly 2 over 4 or 0.5. So it's this, the centroid is 1.5 from F. Then minus delta F equals 0. So solving for delta F equals negative 347.75 over EI. So that's the complete solution to this problem. We solve this into 3 methods. So again, if it is your first time in my YouTube channel, don't forget to subscribe and press the notification bell so that you will be updated of my lecture videos. And of course, I will be more inspired to do more videos. So thank you for watching.